This video is on comparing quadratic functions. Three surveyors are having a discussion about bridges in New York City. The first surveyor collected data from the Verrazano Bridge. He measured the height of the cable as he drove from one end to the other. The second surveyor took a picture of the cable for the Brooklyn Bridge. The last surveyor came up with an equation to model the cable height of the Taponzi Bridge. So we have three bridges here. We have to know that the cables for a bridge, so if these are the posts of the bridge, for the cables would look more like this. These will not have an x-intercept, so it's important to know where the lowest point on the graph would be, but also where does it meet the edges of the bridge. So we need to actually find the y-intercept and the mirror of the y-intercept so that we have more information. We also need to find the minimum, which is that vertex. So when we find this information, this is how we're going to compare these three bridges. So for the Verrazano Bridge, we have a table. He collected the data, so we need to find all of the information using Desmos, and we will use the regression model to find all the information. For the Taponzi Bridge, we have the equation, so we can actually type that in and find all the information. But for the Brooklyn Bridge, we are given a picture of this, and we're also given an equation. So we can actually find this exact information so that we can find the actual coordinates of the y-intercept, the mirror, and the vertex. So let's go and find the information for the Verrazano Bridge. We're going to use Desmos to find this. And then we will find the equation. And then we'll find the y-intercept, the mirror of the y-intercept, and the vertex. So using Desmos, I'm going to type in my table. So the x is the horizontal distance along the road. So we have 0, 100, 200, 300, 400, and 500. Then the height at those feet is 160. Then we have 114 and 4/10. Then we have 77 and 6/10, 49 and 6/10, 30 and 4/10, and then 20. So to do our regression, we want to be able to see this. To do our regression, we'll do y sub 1 tilde. Since this is quadratic, we're going to do our ax sub 1 squared plus bx sub 1 plus c. Remember, anywhere we see a y and an x, we're going to do our sub 1. So now it's going through these data points, and we have the equation of a is 0.00044, b is negative half, and c is 160. So this actual equation is perfect, and we can see r squared is actually perfectly going through these data points. So our equation for the Verrazano Bridge is y equals 0.00044 x squared minus 0.5 x plus 160. So we want to find the y-intercept and the mirror of the y-intercept so we know how long it goes. And then we want to find the vertex. So if we look, we should see the y-intercept is at 0, 160 because that was the constant. So we know this is at 0, 160. So to find the mirror, we know that the y value should be 160. So let's actually find where it crosses at that y value of 160. So we can move this over, and we can see that it'll cross here at 160. So this is at 1,136 and 3600ths. So 1,136 and 3600ths, I'll put 364 since that's what Desmos gave us, comma 160. Because we know the y value, we can actually find the x of that. So to find the vertex of the Verrazano Bridge, it should be at, so this gray dot right here is our vertex at 568, which is half of 1136, so that makes sense. 568 and 182 thousandths, comma 17 and 955 thousandths. So we'll put the vertex at 568.182, comma 17.955. So this is for the Verrazano Bridge. We have all the information for the Verrazano Bridge. So let's go to the Tappan Zee Bridge and find all of the information for this one. So we also want to find the Y-intercept, which we can see should be at 0, 100. But we also want to find the mirror of it so that we know how far it spans. We know that that Y value should also be at 100. And then we also need to find the vertex, so that minimum value. So let's go type this into Desmos. We're going to take out our table. Type in the equation for the Tappan Zee Bridge, which was y equals 0.00025 x squared minus 0.2 x plus 100. So we have 0, 100, and we got to find the mirror, which was that y equals 100. So it also crosses here at 800, 100, and the vertex is at 400, 60. So we have the y-intercept at 0, 100. The mirror is at 800, 100, so that means that this goes 800 feet between posts, and then 400, 60. So this would be 800, 100, and the vertex was 400, 60. So that's 60 feet above the ground is where it is hitting, or where the bridge, the cable stops. So this would be the ground. This would be one post of the bridge, and this would be the other post of the bridge. So we have all pieces of information from the Tappan Zee Bridge. So we're going to do the same thing for the Brooklyn Bridge. We have the actual picture of it, but we do have an equation that represents it as well. So we can find the exact value as well based off of the equation here, but we can see roughly where it should be located. So let's go and actually plug it into Desmos and find the exact locations. So let's write out our y-intercept is at 0, 86 because that's from the constant. We want to find the mirror, which will be at something, 86. And then we need to find our vertex, which will be here. So we have 0.0007x squared minus 0.4729x plus 86. So let's go type that in. Y equals 0.0007x squared minus 0.4729x plus 86. So we have the 0.86. We have our vertex, but we also need to find the mirror, which would be at y equals 86. So let's find our values again. And here's our mirror. So this is where the first post is. This is where the second part of the post is. So our bridge connects those. And then it will start over again. So we have 675.571 for our mirror. And we have 337.786, 6.131. So let's write those down. It was 675.571, 86. And our vertex was at 337.786, 6.131. And so this vertex right here shows that. So it's at 337. It almost looked like it was at 350, so this is why we have the equation to double check it. And then this looks like it was at 700, but it was actually at 675 because we were given the equation for it. So let's go and answer some questions based off of all of this information. First question says, determine the length of each bridge to decide which one is the longest and which one is the shortest. So to determine the length, that means we're going to use that mirror of the y-intercept. So the mirror of the y-intercept for the Verrazano Bridge was 1136.364, or sorry, 364. So 1136.364. The Tapanzi Bridge, mirror of that, was 800. And then for the Brooklyn Bridge, was at 675.571. And these are all in, if we look back at the units, measure the height, it's in, it does not tell us our distance, what the actual, doesn't say feet or meters, so we're just going to say units. So we're going to say units for all of these. So which one is the longest is the Verrazano Bridge, and the shortest is the Brooklyn Bridge because of the values. So Verrazano is the longest, and Brooklyn Bridge is the shortest. Because we were using the y-intercept and the mirror of the y-intercept to know how long from one edge of the bridge to the other edge of the bridge. So from one edge of the bridge to the other edge. Because then the next part of the bridge would do the same thing. It would be another parabola. The next question says, which bridge's cable gets closest to the road, and how do you know this? So closest to the road, if we look back at the cable, the closest to the road, this would be the lowest part. The road is the x-axis. So we want to look at that minimum, that vertex. So the question is really looking at the vertex. So the one with the lowest y value would be the closest to the 0, or to the x-axis. So if we look at the vertex, Verrazano Bridge is at almost 18 feet above the ground. Tapanzi Bridge is 60 feet above the ground, but then Brooklyn Bridge is only 6 feet above the ground. So Brooklyn Bridge is clearly the one that's closest to the ground. So which bridge cable gets closest to the road, and how do you know this? So it's Brooklyn Bridge. Brooklyn Bridge, because the minimum height is 6 131 units above the ground, where the other one was 18 or 60 units above the ground. So we can tell that Brooklyn Bridge would have the lower cable because it almost hits the ground. So which bridge should a trucker use if their truck's height is 15 feet? Which bridge should the trucker avoid, and why? So if the cable is going over the bridge and the trucker is trying to go through onto the bridge to make sure it doesn't hit the cable, we have to make sure that the cable's minimum height at least is above 15 feet. So if we look at the Tapanzi Bridge, the Tapanzi Bridge has a 60 feet above the ground, so we can definitely go underneath that one. The Verrazano Bridge has a minimum height of almost 18 feet. You can still use it, but you might want to avoid it. The Brooklyn Bridge, however, it definitely can't go underneath that one because the lowest point there is 6 feet, so only cars can probably go underneath that one. So which bridge should a trucker use if their truck's height is 15 feet? So they can definitely use the Tappan Zee Bridge. As its lowest point is 60 units above the ground. So they can use that because it's 60 units. Then that trucker might avoid the Verrazano Bridge as its lowest point is only approximately 18 units above the ground. So you need to be careful because the tires might put that a couple feet more or higher. So we got to be super careful to make sure that the cable doesn't hit the truck. But that trucker definitely must avoid Brooklyn Bridge as its lowest point is only approximately 6 units above the ground. So they can definitely use the Tappan Zee Bridge. They might want to avoid the Verrazano Bridge, but they definitely have to avoid the Brooklyn Bridge. And that's all based off of the 3 pieces of information we found for the bridge, for the cable. Because this is, a trucker would go through here, and they don't want to hit the lowest point on the cable. To find out how long the cable is, we wanted to find where this was one pillar of the bridge, and this is the other pillar of the bridge. So then the bridge would actually do it again if we needed to, or it would be underneath on the other side. So the bridge would keep going, and you'd have more cables as it goes. So finding the Y-intercept and the mirror of the Y-intercept told us how long this stretched across, and then the vertex told us how close it was to the ground, because this is where the cars would drive on the x-axis. So we were able to compare these 3 bridges and answer questions based off of the comparison.